Welcome to Brain Vision.
So in this problem, we want to find the magnetic field from a charge of charge q moving with velocity v. So to start, we'll just write down this qv expression for the charge, and we'll kind of just play around with this a little bit and see if we can get anything useful. So a lot of times with velocities, we want to write that as distance over time. So we'll write that just as dl, so moving some length in some time dt. And we can also write this, we can either think of the length changing over time for the velocity, or we can really think of in a given spot, it's the charge that's changing going through there, like a current flowing. So we could also write this as dq over dt times dl. And dq over dt we know is just the current. So this is really just I dl. And so now they tell us to use the Biot-Savart law here. So we know that that tells us that dB is mu naught I over 4 pi, and then times dl cross r vector, so a unit vector in the r direction, over r squared. Now, normally we integrate both sides to get the actual b here, but because we're dealing with essentially an infinitesimally small current here, we don't have a current flowing over continuously through a whole line of wire like we normally do. It's just a single point charge that's in one spot at one time. So we don't actually want to integrate this. Really what we're finding is the dB here, or essentially like it's b, but we're integrating it over no space. So it's just going to be dB. And so now that we have this expression up here, we can see that we could substitute this in for IDL down here. And so doing that, we have mu naught, and then instead of IDL, we have QV, and that's still cross r hat, cross r hat, and then over 4 pi and r squared. So this looks pretty good as it is. I think the answer writes it more in this form. So does mu naught QV, and then rather than using this unit vector, they just replace it with a vector of length r in the r direction, so just vector r. And then if we do that, that means we have to divide by r cubed rather than r squared. So some people might think that looks a little bit clearer, but really it's the same thing, so kind of your preference at that point. But there we go.